All right, we're about a minute after the hour, so we're going to go ahead and get started. Some more people will be piling in as we go, but thank you to everyone that has joined us today. We're excited to kick off today's webinar, Predict, Prevent, Perform AI Networking in Action. Before we dive in, just a quick heads up, the session is being recorded. We're going to send out a copy of that recording to everyone that registered after the webinar. Today's session is about how AI is changing the game in network performance. So it helps teams cut downtime, reduce operating costs, and fix issues before they even happen. We'll be providing practical takeaways, real life examples that you can apply within your own organization. So we'll take a quick look at the agenda here. First, we're going to be hearing from Jay Killian. He's the sales director at Juniper Networks. Jay leads their Mist specialist team for the central US and Eastern Canada. He's got over 20 years of experience and holds dual CCIEs, one in routing and switching and one in wireless. Welcome, Jay, and thanks for joining us. After that, we'll hear from Dan Suen. He is the Chief Technology Officer at Levata Canada. Dan's been designing secure, high-performing network and mobility solutions for over 2 decades. He'll share how Levata helps organizations implement AI networking from strategy and design to deployment and support, and also provide some real-world results companies are already seeing. And then finally, we have about 10 to 15 minutes at the end for Q&A, a live Q&A session. So please feel free to drop your questions into the Q&A box, and we'll answer as many as we can at the end there. And with that, I'm going to just go ahead and hand it over to you, Jay.
All right. Thanks for that. Let's see. Let me share my screen real quick. All right. Greetings and salutations. Thanks to everyone for joining us here today. My name's Jay Killian. I'm going to take just a few minutes and talk to you about what Juniper Mist is doing in our industry. And I'm going to actually start by talking about something that is hot off the press. This broke this past week. You may have already heard the news, which is that HPE has now officially acquired Juniper. We are absolutely thrilled about what's taking place. This is one of the bigger paradigm shifts that we've had in our industry and in our market for quite some time. And if you kept up with the story, the news about HPE pursuing Juniper, then what you will have heard over and over is that HPE, the reason that they were primarily seeking Juniper is because of what we are doing with Mist AI Ops. It is generationally ahead of anything else that's currently available. And I want to tell you what makes it so game-changing and so exciting. But let me first take a step back and talk about where our industry is coming from. And this is where most companies still are. And this is going to help set the table for what makes AI so powerful. Where most companies, where most people are, it's with an architecture similar to what you see on the left. It's the architecture that our industry has been using for the past 25 years. It's served us very, very well. You have your access points, your switches, your network devices. You'll have controllers, you'll have this management overlay that you deploy. And then typically you'll deploy a manager of managers on top of that. And then as you need more services, you would go and duct tape those on to that architecture. And then you would end up with a lot of boxes and a lot of on-premise devices that you stand up, that you manage, you deploy, you keep stitched together. The problem with this architecture is that every attempt to modernize it and to move it into this world of AI automation has fallen on its face to the point every major vendor has already announced and said the future is cloud. We're still doing on-premise boxes while we're working to make that transition, but everything is going to the cloud unless you're in an air-gapped type of environment. What we have at Juniper Mist today is we have the industry's only enterprise-grade AI native cloud that is already deployed and servicing the largest companies on the planet in pretty much every single vertical. Here's what we're doing that makes it so powerful. I'll start with the innovation engine that Mist has. This is our founding team. These are all of our executives. The individual on the far left, Sujay, HPE has already announced they are combining Mist and Aruba into one business unit, and Sujay will be leading that business unit. Sujay is the individual that led Cisco's enterprise business unit, all things wired, wireless, and WAN. Bob Friday, to his right, Bob invented the wireless controller in the late 90s. But Bob is the Gandalf of the wireless world. He invented the controller, started this company, Airspace. Cisco purchased them, and then Bob became the CTO. And this group, they grew that enterprise networking business unit into the behemoth that most know today. In 2011, they led the acquisition of a small little startup called Meraki. Their original intent was to take the cloud automation and simplicity of Meraki, but then combine it with the enterprise grade features, the robust resiliency, the uptime of Catalyst, and give a true enterprise grade cloud. What they realized after looking under the hood and spending a little over a year working on that effort, that it would be like putting a square peg into a round hole. And so they sent shockwaves through Cisco and they collectively left to start something new. And this was Bob's idea. This was his North Star. If someone is having an experience like this on your network, if this video is choppy, if it's not good, how do you know? And the answer 100 times out of 100 is, well, someone opens a ticket or they come by my desk and they tell me. But in every single case, it is a reactive. This event occurred, and then I have to wait for someone to come and tell me about it so that I can go and troubleshoot it. Well, Bob's premise, his idea was this thesis that when events like this are occurring, all of the clues, all of the crime scene forensics that you would need to know what's happening, what's the blast radius, who's being impacted, full root cause analysis, all of that evidence was already there in the network. But it was waiting on someone to come and find it and dig it up and make sense of it. And Bob's premise was that he could use AI to be able to solve that problem and find the signal in the noise, the needle in a haystack better than any human could. And they absolutely knocked it out of the park. This is the latest Gartner Magic Quadrant. It was released about 2.5 weeks ago. If you want to scan the QR code in the bottom right, you'll actually get access to the full report. I'll make it a little bit bigger so that you can see where all of the companies line up. But what we are thrilled about is we've now been in the leadership quadrant, that top right, for 5 consecutive years. And we've been in the pole position, leader of leaders in both ability to execute and having a vision. We are in the pole position for the fourth consecutive year. In fact, this year, that leadership quadrant dropped from 6 companies now down to only 4. So we have 4 companies, and Juniper is leading that pack. What we've done is essentially democratized cloud, where for the first time in history, even the largest, most complex mission critical networks on the planet, they can now adopt cloud networking. These are just a handful of examples of some exceptionally large campus deployments that are all running on Mist cloud networking, because for the first time, the level of enterprise grade features, robustness, uptime, all of those things are now available in a cloud networking platform. There's three things that we do exceptionally well. First, with our solution, you will deploy a network faster at lower cost with fewer mistakes than with any other solution. Full stop. On a good night, Fortune 1 will deploy 3,000 of our access points in a single evening. And it's not just Fortune 1 with their deep pockets. I love the story of Dartmouth College. They deployed 2,000 APs in a single weekend using nothing more than their student body. But deploying access points, deploying switches, that's a small part of overall ownership. This is where it gets really fun. With our solution, you will have fewer tickets that you will resolve more quickly than with any other solution. That's not my opinion. That's not marketing. This is continual real world feedback. One example I'll give you right now is the CTO of UMass College. He was on a podcast. We had nothing to do with it, but he was describing the university's move from a legacy architecture and moving over to Mist. And the interviewer is asking him, what kind of impact did this make in your environment? And he says, well, in our latest semester, we average roughly 100 network trouble tickets in our most problemsome dorms. This past semester, we had two. And the interviewer he stops him and says, "Whoa, whoa, whoa, wait a minute. You had a 98% reduction in network trouble tickets, and all you did is you pulled down one vendor's APs and you put up Mist." And the CTO reiterates and says, "That's exactly what I'm saying. 27,000 students, we had a 98% reduction in network trouble tickets." And then on top of that, we layer in best in breed business outcomes. We do this through first a Bluetooth element that gives a level of location services that is unheard of in our industry without having to deploy complex overlay sensors and things like that. But even more importantly, we have a solution that is 100% open API. I'll give you some examples on that in just 1 second. But I wanted to pause and chat about AI for one brief moment. I want to start by acknowledging this. At this point in history, I'm well aware that when a vendor says they have AI, there's a good chance that you have a Pavlovian eye roll because ChatGPT came on the scene and overnight, every single vendor raised their hand and said, "We have AI too." And then they scrambled to duct tape anything resembling AI onto their existing platform. At Mist, when we talk about AI, this is what our cloud was built for in 2014. We have the industry's only AI native cloud because our cloud was purpose built for AI. Our hardware, our switching, our access points, purpose built for AI. And what you see on the right, all of these are real world customer quotes. On just two that I'll call out here. The engineers at UPS, they have to report every single quarter to the business. What is their average time to remediate a network trouble ticket? The engineers at UPS, their testimony is for 20 years, we were running on a legacy Cisco controller based architecture, and moving to Mist, we have seen a 96% reduction in the amount of time that it takes us to resolve a network trouble ticket. And the last one that I'll talk about is ServiceNow. ServiceNow, they moved their entire infrastructure, a wired, wireless, SD-WAN. They moved all of this onto Mist, and their CIO, gentleman named Chris Betty, he gave us this challenge. He said, if AI is real, if what you're telling me and what you're showing me in your demo, if this is real, I should be able to measure the impact. And so he said, we are going to track every ticket. We are maniacal and we're service now. It's what we do. I will fast forward to today and tell you Chris Betty will stand on stage and say ServiceNow is seen an over 90% reduction in network trouble tickets and moving to Mist. ServiceNow loves this solution so much that they built a full integration package that they built, they support directly available on their their marketplace that stitches directly into Mist, that gives a host of automation between ServiceNow and Mist. So what's our secret sauce? What is it that we're actually doing that is so different from anyone else? Well, here's the five things. First, from inception, our focus has been on user experience. When other solutions are focused on network health, our platform was built from the ground up to capture real world telemetry from your users and then know, are they having a good experience or a bad experience? And if it's a bad experience, why? To the point, we collect 150 different pieces of telemetry from every single client every single minute. Now, that's a lot of data. Good news, you don't do anything with it. And even better, this is all passively collected from our hardware. So you don't have to deploy any clients or anything else. And all of that telemetry is what is then fed into our AI engine. This is when people ask, why is your AI engine generationally ahead? Like, how is it doing so many things that no one else can? Well, the answer is we had a tremendous head start. So we've been actively developing, pushing the boundaries, setting the industry's pace around AI since 2014. Every single week, our data science team meets with our support team. They review every ticket. It's why, as our adoption has done this, our tickets have stayed flat. And all of this runs on a modern microservices cloud. Here's what that means for you. Other solutions that use controllers or legacy cloud solutions like Meraki, for example, they use what's called monolithic code, which means if you want to patch something, if there's a security flaw, if you want to add a feature, well, you go and you update line 4,732 in that code, and you hope that it doesn't break something in line 37,920. Well, we run a modern microservices cloud, which means all of these processes, think of it as their VLAN off. You can start, stop, patch each process independent of the whole. To the point, we had 15 major releases last year, 15 major updates, zero downtime, zero disruption. It's why the world's most mission critical networks, ones that tolerate no downtime, like the Tesla manufacturing floor and Amazon and Walmart distribution facilities, for the first time ever, they're able to standardize on cloud. And we have built into our APs a patented Bluetooth element. This is something that is a Juniper Mist exclusive. I'll give you one example of how this is used by the largest healthcare provider in the world. In their campus hospitals, the way that they are using the Bluetooth element that's built into our APs is first to do turn by turn blue dot navigation in their facilities. But what I like that they do even more is they have completely changed the patient experience, and that they give Bluetooth bracelets to their Alzheimer patients, and doors automatically lock and unlock based on their presence. It's that level of reliable, and it's that level of accurate. And then all of that is underpinned by 100% open API, which isn't just for your DevOps team to be able to take all of this data, all of this telemetry, and be able to stitch it into your own BI systems, although you absolutely can. If you have no interest in the DevOps side, having a 100% open API means it's dead simple to stitch together, take other best in breed solutions, like with a single line of code, with one single API line, the Mist cloud is now fully connected with the Zoom cloud, with Microsoft Teams cloud. We automatically ingest all of that telemetry, all of that feed that's coming from Zoom, from Teams. We marry it together with what we're seeing client to cloud in the network, so that when your CEO calls and says, "Hey, last Tuesday, I had a board meeting and the call quality was bad. What happened?" Well, if they ask you that today, like, you have no idea what happened last Tuesday on a Zoom call. Now you can. Now you can look back at Tuesday and you can see exactly what was causing it, who was impacted, and how do we fix it. I'll close with this. This is a journey that Mist originated in the world of Wi-Fi. And when Juniper bought Mist, they thought they were buying a wireless company that did AI. Turned out they were buying an AI company that was only currently doing wireless. Since that time, we quickly expanded into switching. We have cloud-based NAC for all of those that are sick and tired of having to use ICE. We have the easy button. We have a cloud-based SD-WAN. So you have full client to cloud, one single pane of glass for all things configuration, management, monitoring, and troubleshooting. And with that, I will turn it over to Dan.
All right, my turn. Thank you, Jay. I appreciate it. So my name is Dan Sulan. I'm the CTO here at Levata, Canada, and I just going to talk a little bit about where we fit into the picture. Jay talked about the technology. I'm going to talk about how we implement that technology and the services and the experience that we've been able to provide for our clients. I'm going to start off with listing some common challenges, what we see with wireless networks, and then obviously moving to why we want enterprise mobility, key components of the system, our methods and our approaches, and then I'm going to end off with a real world example of an implementation that we recently completed. So, current state of wireless infrastructure. So, a lot of times we have clients come to us with very similar challenges in regards to what they're seeing within their wireless networks. It's going to be consistent, inconsistent coverage, signal dead zones, legacy devices that have security vulnerabilities that cannot be patched anymore. We have very difficult RF environments that have either interference or are very dynamic, like a warehouse where you one day have material stock in one aisle and the next day you don't. And so it becomes a very, very challenging environment for RF to basically stay consistent. We have the inability to support newer IoT devices on these older networks. Bottlenecks of networking, bandwidth, needs for external or outdoor coverage, and then emerging technologies that are really driving some of the new Wi-Fi requirements. And this could be things like the implementation of new bands like 6 gigahertz, what Jay talked about, the BLE wayfinding, as well as some other beaconing technologies that are really driving the need to change the Wi-Fi infrastructure. And those are evolving demands are really another piece of the puzzle that are driving the need for our clients to look at what's available on the market. The key component here is that, wireless networks are now a strategic asset and are essential for productivity and competitiveness. Like if we had this conversation 10 years ago, Wi-Fi was a nice to have. It was an adjunct to the wired network. We're now in an upside down scenario where wireless is the mission critical mechanism and the wired network is secondary for end user computing. Next slide there, Brendan. Thank you. So why does enterprise connectivity matter? So we talk about the term enterprise connectivity, and think of it like it is a level above of what you would get from a standard Wi-Fi implementation. And this is important because we're not just looking at providing coverage and signal to a device. We're looking at providing a level of service. And that level of service has multiple components. It has a hardware component, a back-end component, and it also has an uptime and support perspective, right? We want to have a level of wireless implementation that will allow us to increase our productivity. It's going to reduce our downtime. It's going to allow for seamless access to cloud and network data. And it's also going to optimize our IT resources and lower our support overhead. So something that's going to be very efficient in regards to how it performs. It's going to have the ability to scale, right? So as we add richer applications, more robust or more devices onto our network, we want that ability for that infrastructure to be able to scale up so that we don't have to rip and replace. We can add on or modify or adjust by implementing newer technologies or firmware or software updates. We want the ability to have the enhanced insights that these types of technologies bring. So, as Jay was mentioning earlier on, the ability to gather all of these information from multiple endpoints, be it a client, be it a switch, be it a firewall, be it a application level service like Teams or Zoom, and be able to pull all that information into one place and actually aggregate that data and make something actual insights off of it is extremely important, because it allows our IT teams to be extremely effective with their time. And also it allows us to be preventative in regards to stopping these types of situations in the future. And then obviously, as the bad guys get better, we have to make sure that the good guys maintain a secure environment. So the big push for making sure that devices are up to date, have the latest security patches, are using the latest encryption algorithms, the latest security protocols. Those are all extremely important, especially from small, SMB markets all the way up to enterprise. We need to secure our networks. Next slide there, Brendan. Thank you. So when we talk about a wireless network, a lot of people just think about the access point, right? There's more to that. We obviously need to have all of the components together to kind of create a robust environment. And the things that are key to this are obviously the routers and access points themselves, right? The Wi-Fi APs, the switches and the control plane, and the control plane now being in the cloud. As Jay mentioned, it used to be the old rack and stacks and all those different pieces of equipment with a manager of managers and all the other fun stuff that were there. The physical cabling that connects all of these things, be it fiber or copper, and the cabinets that hold the switches and the UPS and the power supplies that are required to maintain a level of uptime for these. All of these have their own little life cycles and their time of life before they do need to be replaced. And just to give you a little bit of idea, when we talk to our clients, a typical wireless implementation, if we're buying best of breed or just almost the most modern type of APs, we're looking at about a 5-year life cycle, maybe a 6-year life cycle before we're looking at implementing something new to help support the newer devices or the newer bandwidth requirements. Routers and switches are a little bit of a longer life cycle just because they're a little bit more static in regards to what they're doing. They usually have high bandwidth, large trunks back into their distribution layers. And the WAN controllers and firewalls, a lot of those are being built into the routers and are being virtualized as well and managed by the cloud, or even augmented and sent right into the cloud through SD-WAN infrastructure. So the lifespan of those is a little bit longer, but we're finding that we're virtualizing a lot of these pieces of equipment. So all of those pieces are kind of what are required to create a robust network. And this is where we can step in and help you out. Levata is an organization that provides enterprise-grade networking to our clients. And we have a very typical approach that we use for basically providing this level of service. And it starts off with, designing a network architecture. We want to make sure we understand what the needs of the client are. We want to make sure that we understand what their goals are today, what their goals may be in 3 and 5 years, so we can properly architect a solution that's going to be able to support that without having any dead ends or bottlenecks in that aspect. Site surveys, extremely important for us to physically see what is going on in the environment and be able to model that on software and determine where access points should be placed, what channel adjustments, what power levels, all of that stuff. Now, a good portion of that now is done through AI within the actual Wi-Fi environments that Juniper has. But having a good base design to start off on is integral in regards to having the AI to be able to adjust these things. Installations, obviously, we have a service that will go out on site. We'll do structured cabling, we'll do configuration, we'll do the physical access point mounting, racking, switching, building IDF closets, power, all that fun stuff. And then once everything is up and live, we do network integrity testing. So what we designed, what we installed, we validate afterwards with testing. Next slide. So I talked about site surveys, and site surveys, there's two types of site surveys. There's on-site site surveys and there's predictive site surveys. I'll talk about predictive in a bit. On-site site surveys, we go into a facility and we actually have special tools that measure the RF in an environment. So we can't see RF, it's invisible to our eyes, right? So we have a tool that will look at the 2.4, the 5 gigahertz, and the 6 gigahertz spectrum. Those are the spectrums that the RF spectrums that Wi-Fi works on. And we'll actually measure those signals from your Wi-Fi, from adjacent Wi-Fi, and even from non-Wi-Fi pieces or RF that are within those channels. And we'll be able to visualize it and see how things are performing and also how they're interfering, right? So on the left here, we can see that the gray regions are indicating a dead zone in essence where there's not enough coverage because we set a criteria to say, hey, if we don't meet a minimum signal level, define it as gray. We redesign the network, we remeasure, and you can see that our post-install and survey, we're all green. We're all meeting those minimum requirements. That's a very, very important step in regards to designing and implementing a wireless network. Next slide. Thank you. With the implementation, we also need to know the backbone that these access points are going to be connected to is robust. I look at it as like, I just bought myself the Ferrari, but I went out and put the cheapest tires on it as possible, right? So I will burn out and you know, make a lot of smoke, but I'm not gonna be able to corner. I'm not gonna be able to accelerate fast, right? So we want to make sure that the backend systems are properly architected to make sure that they can support the bandwidth and the networking requirements that those edge points those are going to require. We have a full team of certified engineers that will go and redesign or augment to design a network that you have within your facility and see what we can do to update it and replace it or add on to it to basically make it more robust. Next slide. Predictive surveys, we talked about where we have surveys that we do when we're on site, but prior to that, we use modeling software and we take your facility and we actually look at it. We put in RF attenuation values of all of the different pieces of equipment, your racking, your walls, your windows, all that sort of stuff. And we can actually model with a fairly high accuracy what the RF environment is going to look like post-installation, you know, 95+% accuracy. So we use this as a tool to design the RF so that when we actually go and run cable and we actually hang an access point, we are certain that we're not going to have to go and move that AP 20 feet to the right and you know, spend a lot of extra time and money redesigning something that could have been designed from the beginning. And this is a key component to any RF network installation. Especially, sorry, before we move to the next slide here, a lot of people say, oh, I already have an RF survey. I already know where my APs are. And that's true, but with Wi-Fi 7 and Wi-Fi 6E now implementing 6 gigahertz band coverage, that changes the propagation of RF primarily on that band. So the assumptions you had for AP coverage with, let's call it Wi-Fi 5 and Wi-Fi 6, may not be transposable to Wi-Fi 6E and Wi-Fi 7. So it's always good, best practice to redesign your RF network through a predictive survey. Next slide. And then obviously, once we have the design, we have guys, we have teams, we have people that can run the structured cabling, rack and stack equipment, physically install it. We work with your projects teams to basically get into your facilities, or we work with your facility teams that may already be doing cabling for you, and we provide the design documents that allow them to go in and implement this. Next slide. So I'm going to finish off with a real world example that we did. We have a client up here called the Beer Store, which is one of my favorite stores. It's also known as BDL, which is the Beer Distribution or Brewers Distribution Limited out in the Western Canada. So they are a beer distributor across Canada or Ontario and West. and they operate about 300 retail locations in the Ontario space. And they have been a client of ours for a while, and we implemented a Wi-Fi system about 10 years ago for them. It was a legacy system now, and they've started to struggle. It's showing its age, and we had some challenges. Their existing system was 802.11 AC, access points that were centrally managed with an on-premise controller, some newer Wi-Fi 6 APs that were cloud managed. So it's kind of a mixed bag of deployment just based upon where things were in the life cycle and when stores were being opened or distribution centers were being built. The challenges that they were experiencing, they had end of life and end of support for equipment. There were no more updates available, firmware, software patches for their legacy Wi-Fi 5 access points. They had a hybrid managed environment where new APs were in the cloud, their old APs were on premise. There wasn't a single pane of glass to kind of see everything and how it was interacting. It was a lack of diagnostic tools because it was legacy APs. It just wasn't the capabilities. Their bandwidth requirements were growing. They were implementing applications like voice pick and richer applications at the retail space, and they had poor captive portal capabilities as well. Their goals were to upgrade the network to support new applications and devices, modernize their Wi-Fi system with advanced troubleshooting and self-healing capabilities, centralize the management for these in the cloud, and also allow for future proofing of managing other network endpoints, be it firewall switches or newer APs. Long-term support, so having a roadmap, knowing that anything that they're investing in is going to run the length and not be end of life and not be supported. And flexible architecture to allow for mixed deployments and future expansion. So can I mix this Wi-Fi technology with this Wi-Fi technology and buy the best of breed equipment for the different types of physical spaces and environments that I have? And then obviously they wanted to recognize a return of investment. Next slide. So here was our 5 phases in regards to this deployment. We started off with the discovery. So we determined, what were the customer's needs, where they were trying to go today, tomorrow, and 5 years from now. We developed a technical scope and success criteria for this deployment. We then went to a design phase where we identified OEMs with offerings that met this project criteria. We performed site surveys to design the network layout and structured cabling requirements. And then we put forth a couple of proposals, right? Once we had those proposals in place, the customer wanted a bake-off. They wanted to validate, what is going to work best for them in their environment. So we built out lab environments for the customer to test out potential options. And then we worked with the customer to actually do pilot POC installations in their production environment and do A/B testing in that sense. The outcome of that was they chose to go forward with the Mist Juniper solution set. I'll talk about some of the reasons why afterwards. But once we got that, this is the direction we're going. We worked with them and their project team to coordinate the installations. We provided structured cabling, configured and installed the new access points, new network equipment. We performed post-site surveys. And we also did any sort of system tuning and adjustment based upon what we found from those surveys. And then the last thing, as a post-install, we made sure that the customer was trained and knew how to operate and utilize the tool sets and the capabilities of their new network. We provide tier 2 and tier 3 technical support for network issues for the client. And we also provide hardware failure on-site replacement if something were to happen. If there's a physical damage done to an access point, for instance, someone hits it with a forklift, we have a spare pool. We'll go on site and replace that for them. Next slide. And then the project outcome. So the new system, as I mentioned, was a modern Juniper Mist Wi-Fi 6E scenario that's all cloud managed. They would have gone with Wi-Fi 7, but it wasn't out. They were a little bit early, but Wi-Fi 6E hits a lot of the bells there. Challenges that were overcome. We now have a cloud managed environment that's always up to date and current, talking about those microservices that Jay mentioned there, so we don't have to forklift upgrade everything all the time. It's a unified network with integration into the customer's Juniper firewalls and switches. They were also a Juniper firewall and switch customer, so there was an added benefit there. They have the Marvis AI and advanced troubleshooting now tools that are now available to them that allows for a lot of the self-healing and let's call it investigation tools that allow IT staff to be a lot more productive. Higher bandwidth APs with the addition of the 6 gigahertz band, so we now have a better balance for their modern devices, and a robust captive portal for guest management, which integrates into their employee sponsorship. So if I go to their site, I will say I want to join their guest network. Who am I here to see? I put in Jay Killian's name. Jay gets an email, says, "Hey, Dan Sulan is here to see you. Would you like to grant them guest access?" Yes, I would, and I automatically get onto their network. Goals achieved. We upgraded the network to support new applications and devices. We modernized their Wi-Fi system with advanced troubleshooting and self-healing capabilities. We centralized their management and allowed for future expansion of network nodes. We have the long-term support goal that we hit, a flexible architecture for mixed deployments, and then they recognized an ROI in their investment because they were able to lower their IT overhead, reduce their amount of trouble tickets, and their performance in their warehouses and distribution centers went up because there was less application issues as well. And that's where we left off, and they're a happy customer, and there we go. Brandon, it's up to you
Awesome.
now.
Yeah. Thank you both for sharing your insights and a great look at how organizations are kind of putting those solutions into place. We got a little bit of time left here for some Q&A. We ran a little bit long. If you haven't already dropped any questions into the Q&A chat box at the bottom of the screen, I think it should be, please go ahead and do it. I can take a look here if anything's come in. And I have a few questions that look like they come in. So one question is this solution realistic for small to mid-sized businesses in terms of cost and complexity?
100%. I'll
Yeah,
at
you
least
want? Go for it.
I'll at least say on the mist side, it is absolutely price competitive with any other major solution that you would see.
I agree there, and I would almost argue that the AI capabilities and the smarts built into the system actually benefit smaller businesses because they don't have that dedicated staff or they don't have those dedicated expertise, and it's like putting it in autopilot. Off you go. Right?
Great point.
Awesome. Another question. What does the typical implementation timeline look like from kickoff to full deployment? Maybe that's a Dan question.
Sure.
Or both.
So the answer to that is it depends. I can tell you the real world example that I provided there, from the time when we started the conversation with the customer to the point where all 14 of their distribution centers and their head office were upgraded, was about a year, right? But I would say in about maybe 3 months of that at the very beginning was their validation, going through the testing process, identifying which solution they wanted to go with, and then making that choice and moving forward. But typically, if it's a smaller environment or a single or a greenfield environment that doesn't really have that existing infrastructure, it's a very quick installation. To Jay's point, these are plug and play. You plug them in. You have some templates within the controller or the wireless cloud environment that can provision these very easily. And it just requires a bit of structured cabling, and that's something that we can organize very quickly in regards to a few days to a couple of weeks. So I wouldn't say it's a very long deployment time.
Awesome. I got one more here. Let's see. Can this solution integrate with or support older legacy devices that are still in use?
I'm
Yes.
assuming like wireless stuff, right? Yeah.
Yeah, this is even if you get the latest and greatest Wi-Fi 7, it's backwards compatible with all of your prior devices. So yes, we have a host of legacy devices from across the globe that are all working wired, wireless, WAN. So yes, absolutely.
Jay, maybe I can piggyback on that and ask you, in a scenario where you might have an older device that maybe isn't as secure as some of the newer devices out now, what would be a good strategy to kind of allow for both a newer, secure, modern, Wi-Fi 6 device and something that is a little bit more legacy, maybe an IoT sensor that you might be a little bit, concerned about? Like, how would you approach that?
Yeah, so there are some really interesting ways that we now have that are much more scalable to be able to secure devices that might not support modern methodologies like being able to use certificate-based authentication, or they don't have Active Directory credentials and things like that. We have a specific type of PSK pre-shared key that essentially allows you to rotate at scale a key secured connection without requiring you to go to every single device and every 30 or 60 days log in and change that password. So to your point, Dan, we can give a secure, reliable connection to everything from the latest phone, latest Mac, latest whatever, all the way back to I have a legacy Zebra handheld or a light bulb that exists in the ceiling. We have ways to secure all of that at scale.
Awesome. Thank you.
Great. Thank you both. Yes, we've come to the end of our time here. I just want to say thank you again to everyone that joined us today. Big thanks to Juniper and Jay for speaking, and Dan as well, and sharing your insights. Um, as a reminder, we will be sending this webinar recording out to everyone that registered, so please keep an eye out for that in your email inboxes. And if you have any follow-up questions or want to continue the conversation, please feel free to reach out. You can scan this QR code here as well, or reach out to your Levata account manager. So thanks again, everybody, and we hope to connect with everyone soon.
Thanks, everyone.
Thank you, everyone. Take care.